Hi everyone, this is our third question from Digital Electronics. Here is the question. The logic realized by the below circuit in its reduced form is, here we are given a 4 cross 1 mux having 4 inputs I0, I1, I2 and I3 with values C1, 0 and C bar and two select lines S1 and S0 having values A and B with an output F. Before we proceed, let us look at the prerequisites. To understand this question, we must have a clear idea about the consensus theorem. We can understand this using these two examples. So let us look at the first example. Y is equal to AB plus BC plus CA bar. Here you can notice that the literal A has both its normal form and its complemented form, whereas the other literals B and C are having only their normal forms. Under these conditions, check the literals which are linked to this A and A bar. Here they are B and C. So the product of those two, B and C, should also be there in the expression, and as per consensus theorem, this particular term BC will be neglected as it is a redundant term. So y is equal to AB plus CA bar. Next example, y is equal to A bar B bar plus B bar C bar plus A bar C. Here you can see that C is the only literal having both its normal form and its complemented form, whereas the other literals A and B are having only their complemented form throughout this expression. So observe the literals which are linked to C and C bar, which are A bar and B bar. And luckily, this A bar and B bar are present as a product term in this same Boolean expression. So as per the consensus theorem, this A bar B bar is neglected and this is the final output which is received. Y is equal to B bar C bar plus A bar C, as A bar B bar is considered to be a redundant term. Next, we come to this Boolean formulae, which is x plus x bar y is equal to x plus y, and x bar plus xy is equal to x bar plus y. Here, the terms x bar and x are to be neglected. Now, let us revise the 4 cross 1 multiplexer, which is the mux. So, this number 4 indicates the number of inputs, and this number 1 indicates the number of outputs. This 4 can be written as 2 power 2. This power 2 represents the number of select lines. In this question, I will be only following the sum of products form, which is sum of minterms. So the procedure is as follows. Take the two select lines S1 and S0 and write all the two input combinations 0, 0, 0, 1, 1, 0 and 1, 1 and write the corresponding minterms. The procedure to write the minterms is as follows. Whenever you see a 1, take the complemented form of that particular literal, and whenever you see a 1, take the normal form of that particular literal. So what happens in a mux is, whenever S1, S0 is 0, 0, then the input 1, that is the first input here, which is I0, will be accessed by the output. And when S1 and S0 are 0 and 1, the input I1 will be accessed by the output. The same follows for the 1, 0 and 1, 1, where the inputs I2 and I3 are accessed by the output respectively. So let us go back to the question. Here it is given that C, 1, 0 and C bar are the four inputs and A and B are the select lines and F, which is the output, is asked by us in its reduced form. So consider the two select lines A and B and write all possible two input combinations 0, 0, 0, 1, 1, 0 and 1, 1. So as we have already done this in the prerequisites, let us write the output expression. So for 0 and 0, both A and B must be complemented. And the first input, which is C, must be written as a product of it because 0, 0 will access the first input towards the output. Secondly comes the 0 and 1. Here A is in the complemented form and B is in the normal form, written as a product with the second input, which is 1. Next comes the 1 and 0. Here A is in the normal form, B is in the complemented form, and the third input, which is 0. Next we have A and B as 1 and 1. So both are in their normal form, A dot B, and the fourth input, which is C bar. Now this output is simply all these minterms added together. So A bar B bar C plus here A bar dot B bar dot 1 is simply A bar dot B because anything into 1 is that anything itself. A bar dot B and 0 into anything is always 0. So I'm ignoring the third minterm and I'm directly considering the last minterm, which is plus A, B, C bar. Now here I can see that this A bar is common. So B bar C plus B plus A, B, C bar, which is here you can see that B plus B bar C. So as per the Boolean formula, this B bar must be neglected. So A bar into C plus B plus A, B, C bar. Now let us expand this. A bar C plus A bar B plus A, B, C bar. Now let us check for any common literals. Here we can see that taking B common, A bar plus AC bar plus A bar C. Here it is given A bar plus AC bar. So here the term A is neglected as per the Boolean formula which we have discussed in the prerequisites. So B into A bar plus C bar plus A bar C, expanding again A bar B plus B C bar plus A bar C. Now here you can see that this A is having only its complemented form, this B is having only its normal form, and this C is the only literal having both the normal form and the complemented form. So let us use the consensus theorem. So to this C and C bar, the linked terms are A bar and B, and these A bar and B are luckily present as a product term in this expression, A bar dot B. So as per the consensus theorem, the output function f is this A bar B must be neglected as it is a redundant term. So the final answer is A bar C plus B C bar. So this is the final answer. Thank you.